In this exercise, we are going to do 3 examples where we are going to make our own diagram to figure out the value of certain trig ratios. We're not allowed to use our calculators, we can only use our diagram. So let's jump in and do that. We have looked at introducing the Cartesian plane and angles forming on the Cartesian plane. We've looked at figuring out which quadrant are we supposed to work in based on the sign of the given ratio, whether it's positive or negative. Then we looked at when they give you the diagram and we just have to figure out the problem that they give us. And now we're going to make our own diagram. And they give us that if tan theta is equal to 7/4 and theta is bigger than 90 and smaller than 270. So theta is between 90 and 270. Okay, so there is our 2 pieces of information. From this one, tan theta is equal to 7/4. Well, we know that tan is equal to opposite over adjacent, so we already have that information there. We can see that our tan ratio is positive. So if we make just a rough sketch there of our cos diagram, that helps us figure out which quadrant we're supposed to be in. So our cos ratio is given as positive. So it can be positive there and it can be positive there. If we consider the second given piece of information, that theta needs to be between 90 and 270. So 90 degrees is there, 270 degrees is there. So between those two must be there. So it overlaps in this quadrant. So that is where we are going to draw our triangle. Let's go ahead and do that. I just want to put in some straight lines for us. All right, so we are in the third quadrant. And let's just keep reading. Now we need to make use of a diagram to find the value of this, and we are not allowed to use our calculators. All right, so a dead giveaway. In this case, they told us make a diagram, so that's pretty much a dead giveaway. But often when they give you those 2 pieces of information and they say that you can't use your calculator, that would be an indication that we need to make our own diagram. So let's go ahead. There we've got our triangle. There we've got our coordinate. We'll see how much information we've got there. So we've got 7 and 4. So our opposite is 7 and our adjacent is 4. So our hypotenuse or our radius is missing. But now we must just be mindful. Think about the quadrant that we are in. In this quadrant, our x value will be negative. So that point over there will be -4. Why did I put in a +4 there? Because it is our side length. It's the side length of a triangle. And in that quadrant, our y value will also be negative. So when we are building our ratios, we are going to use those. And do you see why our tan ratio is positive in that quadrant? Because it will be our opposite over adjacent. And when we divide those two negatives, it will give us a positive. Okay, let's put in our theta, and let's see if we're going to need our hypotenuse. Well, since what we're supposed to find is cos, we're definitely going to need the hypotenuse. So again, we're going to use theorem of Pythagoras. So we've got 4 squared plus 7 squared is equal to the longest side. You can use an h or whatever you want, but I'm going to use r squared just because it represents the radius of our unit circle, right? Please make sure that you watch that video if you haven't. Oh, that was pretty good. Okay, let's simplify that. That would be 4 squared plus 7 squared. And that would be 65 is equal to the radius squared. But we don't want that squared. So we're going to get the square root on both sides. And then we will get that r is equal to square root of 65. Leave it like that. Because otherwise, if we go write that as decimals, we need our calculators to do that. And we don't want that for this question. So we found that one to be the square root of 65. All right. And now let's get to the actual question. We need to find the value of this. And just note, cretins, they're not asking us to find theta. They're asking us to find the value for cos squared theta. And this means that cos theta, whatever it is, needs to be squared. So let's go see what cos theta is. So cos is equal to adjacent, watch your signs, adjacent over hypotenuse. And we know that cos is supposed to be negative in this quadrant, right? So it makes sense. And, oh, we need to square that. Almost forgot. And when we square that, we're going to land up with positive 16 over 65. And that is our final answer. We answered the question, drew our diagram. On to the next one. All right, let's read. If 2 sine theta plus 1 is equal to 0 and theta must be bigger or equal to 270 degrees. Okay, so these are two pieces of information that's going to help us figure out which quadrant we're supposed to be working in. And then we need to determine the value of this. So that is what we need to answer. And this information we're going to need to draw our diagram. Okay, we're not allowed to use our calculator. This one didn't specifically say use a diagram, but you need to know that. Let's go ahead and draw a diagram. I'm just going to put some straight lines in there for us. Okay, let's use a rough sketch for the cos diagram to help us just figure out which quadrant we are in. So we first have to take this trig ratio and just isolate the trig ratio. So I am going to take that 1 over, subtract a 1 on both sides, and then I'm going to divide both sides by 2. So therefore, isolating our trig ratio is equal to negative a half. So it means that sine is negative. Where is sine negative? Well, sine is negative there and there. So that's not enough information because that's two quadrants. How are we going to know which one we're supposed to be in? So that's where we consider the second piece of information. And also, theta must be bigger or equal to 270. So that means it limits us to that quadrant because 270 is there. And if it's bigger than that, it must be in there. So they overlap there. So we are actually working in the fourth quadrant. Let's go draw our triangle. There we go. In the fourth quadrant. And let's consider the information that we have there. Well, we know that sine is equal to opposite over hypotenuse. So in this case, if we go put that information on our diagram, this one will always be positive. And then our opposite is 1. I'm just putting that as a positive because it represents the side length of a triangle. But that means that my y value is a negative 1. And that is the one that we use in our ratios. So what is missing? It is our x over there that is missing, which is the adjacent side of our triangle. So let's quickly use Pythag to go find that. That would mean that our x that is missing, squared, plus our 1, which is the other short side of our 90-degree triangle, would be equal to the hypotenuse squared. And that is using the theorem of Pythagoras. So that would mean 2 squared minus 1 squared. So x squared is equal to 4 minus 1, which is 3. So therefore, x is equal to square root 3. And leave it like that because we are not using our calculators. So we don't want to get decimals there. So our adjacent is equal to square root of 3. Positive or negative gradients? Well, think about the quadrant that we're in. Our x values will be positive there. So it's just square root 3. All right, there our diagram is complete. Now let's see what we're supposed to answer. That. So if we get 2 cos squared theta plus sine theta over 3. Okay, perfect. We are supposed to find that value. So for this one over here, that would be 2 times whatever cos is, and that needs to be squared, plus whatever sine theta is, and we're going to divide that by 3. So let's complete that. Well, we already have the sine ratio that was given to us as negative 1 over 2. And what is our cos ratio? Well, the cos ratio would be adjacent over hypotenuse, and we check our signs. Yeah, that's perfect. And now we just need to simplify this. So 2 times, I'm first going to square that one. If I square that, the square root of 3 squared, so it's the square root of 3 times the square root of 3 is just 3 over 4. And then we are going to add, well, over there we've got, I'm just going to do this. I don't want a fraction over a fraction. So I've got negative a half that is being divided by 3. So I'm just going to write that as 3 over 1. I'm just showing all my steps. I'm sure at some point, and maybe a long time ago, you already started reaching for your calculator. So if we multiply, that one is also over 1, right? So we can just cross cancel that. So it means that over there, we will land up with 3 over 2. And then plus, over here, we are going to land up with negative a half that is being multiplied by 1 over 3, because that's how we divide our fractions. And then we've got 3 over 2. And then if we multiply those two, well, we've got a positive and negative. That would land up giving us a negative, and this would be 1 over 6. All right, we need a little bit more space. And let's make those denominators the same. Let's make it a denominator of 6. So then with this one, we have to times that by 3, times that by 3, which will give us 9 minus 1. And our final answer would then be 8 over 6. Goodness. And then we can simplify that to 4 over 3, which can also be 1 1/3. Goodness me. And there we answered the question. We found the value for 2 cos squared theta plus sine theta over 3. It's testing more our fraction knowledge than our trig knowledge. But I mean, if you go and you test that and you put that in on your calculator, you can do that. Even though the question is without your calculator, sure, but it's just that they don't want you to use your calculator for the trig, like to find the theta. So obviously, if you work it out without the calculator, that would be great, because this is fraction knowledge that you have. Okay, on to the last question, where we're going to draw our own diagram. So if this is true, and that is also true, we need to calculate without using a calculator the value of those following 2 questions. Okay, we can do that. Let's just put in some straight lines. Nope. There we go. Okay, first thing that we're going to do, let's go figure out which quadrant we're supposed to be working in based on the 2 pieces of information that we were given. So if we take our trig ratio, we've got our 5 cos beta is equal to negative 3. And then we divide both sides by 5. Then we land up with that. And we already have a lot of information, because we know that cos beta is equal to adjacent over hypotenuse. All right, if we consider that information, we can see that our cos has a negative ratio. It's negative, so cos is negative either there in the second quadrant or the third. But we need some more information, because how do we know which quadrant we're supposed to be working in? And that's where our second piece of information is quite helpful, where it says that sine beta needs to be bigger or equal to 0. So sine needs to be positive. So where is sine positive? Sine is positive either there or there, and that is where both those pieces of information overlap. So that is where we're going to work. So there is our triangle. That is a terrible attempt. I'm going to try again. Okay, that's a bit better. There is our triangle. And let's go put in all our information that we have. We have our hypotenuse, our radius for our unit circle. Remember, this represents our unit circle, or just a circle, kind of circle. Okay, and then we've got our adjacent over here, which would be 3. And our x value, so it is a negative 3. I'm just writing it as a positive there because it represents the side length of a triangle. But it is a negative 3 because of the quadrant that we are working in. So we don't have that y value. We can find it by using the theorem of Pythagorean. So let's quickly go and build that. The 2 shortest sides, so my y squared plus my 3 squared, is always equal to the longest side, the hypotenuse, according to the theorem of Pythagorean. And then if we just quickly solve for y there, we've got 25, and we're going to subtract 9. So y squared is equal to 16, and therefore y is equal to, well, technically plus or minus 4 if we square root both sides. So we're going to square root both sides to get y. And then we know that y is equal to, well, it will be positive 4 because in that quadrant, our y will be positive. Okay, and now we've got all the information that we need to go answer these questions. So let's go do that. Without a calculator, we are going to find the value for 1 minus cos squared beta. And that means that 1 minus whatever cos beta is needs to be squared. Well, we already have that. They gave that to us in the beginning, which is negative 3 over 5. And then if I square that, it would give me 9 over 25. And if I make those denominators the same, because that's how we subtract our fractions, that will give us 16 over 25. So we found the value of number A, 1 minus cos squared beta. Now we are on to number B, last one. Let me just create a little bit of space. So for beta, for B, we need to find the value of 2 tan beta plus 7 sine squared beta. We can do that. So it will be 2 times whatever tan beta is plus 7 times whatever sine beta squared is. So let's go replace tan beta using our diagram. So tan is equal to opposite over adjacent, which is a negative 3. And it makes sense, right? Because in that quadrant, in the second quadrant, our tan ratio needs to be negative. And it is, so that makes sense. Let's go replace our sine ratio. So sine is equal to opposite over hypotenuse. And our sine ratio over there is positive. Does it make sense? Yes, because in that quadrant, our sine ratio will be positive. Otherwise, you need to check and see if maybe you made a small error somewhere. So now let's just quickly work that out, showing our steps. So that would mean if I just go put that 1 over 1, since we are dealing with fractions over there, it would be 2 over 1 times 4 over negative 3. So that would give us, what is that, 8 over 3, and that would be negative. And that would be plus 7 times, well, if we square that, that would give us 16 over 25. And there we've got large numbers, but that's okay. 7 times 16, so that would give us that, and then plus 112 over 25. And this is not the best fraction, but that's okay. We can make our denominators the same. Let's make it, let's just multiply them by each other. So that would be 75. So it means that I'm going to times this one by 25 and that one by 25. And if we do that, then we are going to land up with 200 there. And this one, we are going to multiply with 3. So we're going to multiply that one with 3. And that gives us 336. Let's just create a little bit more space. And if we put that together, that will give us 536 over 75. And if we simplify that, I guess we just need to figure out how many times we can leave it like that, but I feel like simplifying it. How many times does 75 go in there? So 75 goes in there 7 times. And then it means that there will be, I think, 11 over 75 left. That's just practicing simplifying our fractions, but that is perfectly fine. And we're done. We answered the question. I would suggest trying these on your own. There's always one of these questions in your tests and exams, and it is important to understand going into grade 11 and 12.